Okay, so now we're going to start graphing quadratics, just like we went back to graph absolute values. These are a little bit trickier because we're not talking about in transformational form, in vertex form. Now we're going to be talking about standard form of a quadratic, which is where you more commonly see them. So standard form of a quadratic is f of x is equal to ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is a constant. So that's what that represents. It's always, a is always the number before x squared. So a parabola is a U-shaped graph of the quadratic. If your a value here, and we actually already looked at this, if your a value is greater than 0, if it's positive, it's going to be concave up, so your quadratic will look like this. If a is less than 0, then it's going to be concave down, so it's going to look something like this. Okay. The turning point of the parabola is called the vertex. To find the x value of the vertex, you use the formula negative b over 2a. And so those a and b, those are the those come from the up in the standard formula. Okay. If the vertex of the parabola is the lowest point, so this would be when it is concave up, then it is called a minimum. If the vertex of the parabola is the highest point, like this one right here, this would be a maximum. Okay. The vertical line that divides the parabola into two equal parts is called the axis of symmetry. Okay, and so every parabola has an axis of symmetry. This one right here would be this line right here and this line right here. And the axis of symmetry also has a formula very similar to that formula, and we're going to talk about that in just a moment because I'm going to actually go down and do a few problems here. So this is find the vertex and sketch a graph of the quadratics below. So just to reiterate, in this case, a would be -1 because that's the number in front of x squared, b would be 6, and c would be 0. Now, c doesn't come into play, but it will come into play a little bit later. I already know that with this negative right here, that this is going to be a concave down graph. Okay, this is going to have this is going to have a maximum. Okay, and we'll look at that. So I'm going to find my vertex. I gave you the formula. It's negative b. So to find the x value of your vertex, so it's going to be negative b over 2 times a. So that's going to be -6 over -2, which is 3. So that's the x value of my vertex. To find the y value of your vertex, you actually plug it into the original equation. So my original equation is f of x, or y, is equal to x squared plus 6x. I'm going to substitute 3 in. So y is equal to -3 squared plus 6 times 3, which is -9 plus 18, which is going to be, so my y value is going to be 9. Okay, so my vertex of my parabola is going to be 3, 9. So it's going to be somewhere up here, and I know that my graph is going to be concave down. Okay, and so my vertex is 3, 9. Now my axis of symmetry, and this is just a little factoid that you need, would be this line right here. And the equation of this line is actually going to be x equals 3 because it goes through my x value of 3, and vertical lines are x equals 9. That's from algebra. So my axis of symmetry formula is going to be x is equal to -b over 2a, or x is equal to the x value of the vertex. Okay, it's always x is equal to the x value of the vertex. We'll talk about this later, but when we talk about real solutions, that's where the graph crosses the x-axis. I wanted to make sure that that was somewhere in your notes. So in this case, my axis of symmetry is x equals 3. So the next one, in this case, a is equal to 4 and b is equal to 0. I know that since this is positive, it's going to be concave up. Okay. I'm going to find the x value of my vertex and also my axis of symmetry at the same time. -b, so -0, over 2 times 4, which is 0 over 8, which is 0. So my axis of symmetry is going to be x equals 0, because that's the x is equal to, that's my line, the x value of my vertex. That's going to be 0. So then to find the y value, so y is equal to 4x squared, y is equal to 4 times 0 squared, which is equal to 0. So the vertex of my parabola is 0, 0. So what would my graph look like? It's going to look something like this. Okay, and so we can check these in Desmos. So negative x squared plus 6x. Negative x squared plus 6x. Does it seem about right? My vertex is at 3, 9. Okay. And my other one is 4x squared. So let's graph that and just check it, 4x squared. And so there we go. And it's kind of a little bit more narrow than I thought it was, but that's good. All right. So now let's talk about actually graphing. So that's just a nice sketch, but it actually isn't doing the actual graph. So just graph the functions below and identify the characteristics listed. Okay, so the first thing you need to do when you graph, and we'll worry about all of this stuff, is you find the x value of the vertex, then you find the y value of the vertex, write the vertex in the middle of the table. Okay, so let's start with that. Okay, so for this, I know a is equal to negative 3, and my b value is going to be 0. And c in this case is, my c value is 5. So, x is equal to negative b over 2a, which is going to be 0 over negative 6, which is 0. Okay, so that's the x value of my vertex. The y value of my vertex, I plug the x value in, so that's going to be negative 3 times 0 squared plus 5, which is going to be 5. Okay, so that's my first point, 0, 5. Okay, now let me find at least 2 other points to give me my shape. So I'm going to pick 2 points to the left, so I'm going to go with negative 1 and negative 2. I'm going to pick 2 x values to the left, and then positive 1 and positive 2. So 1 space over, and then 2 spaces over. And how I'm going to find the y values of those is I'm going to plug that into the original problem. So to find the y value where it's negative 1, that's going to be negative 3. Make sure you put this in parentheses, negative 1 squared plus 5. Y is equal to negative 3 times 1 plus 5, which is equal to 2. Okay, I put negative 2 in. Y is equal to negative 3 times negative 2 squared plus 5. Y is equal to negative 3 times 4 plus 5. That's negative 12 plus 5, which is going to give you 7. I do the same thing on the other side. So it's going to be y is equal to negative 3 times 1 squared plus 5, which is going to be, if you plug this in, you can even plug it into the calculator, is going to be 2. And y is equal to negative 3 times 2 squared plus 5 when you plug it in, which is going to be 7. And that's all you need. You need just 2 points to the left, 2 points to the right. Left a little bit of space to find the other ones. So I plot my points. So negative 1, two, and negative 2. Oh, I know what I did. This should be a negative 7. Sorry about that. That should be a negative 7. And then negative 2, negative 2, 2, 4, 6, negative 7. And then on the same side, you can actually kind of plot the points because it's symmetric over your axis of symmetry. And then there you go. Sorry, my brain stopped working for a second because I knew it was concave down. Okay, so that's a sketch of your parabola. You just find points, you find your vertex, pick 2 points to the left, 2 points to the right, plug it in, and then draw it. And honestly, if you do a good job, these y values will be the same as these y values as long as you pick the points that are symmetric on each side. So for this, my vertex was 0, 5. It is a maximum because it's the top. My axis of symmetry is going to be x is equal to 0 because it's x is equal to the x value of my vertex. My domain, my x's, I can plug any number in for x. I have no restrictions, okay? And so, and domain for all of your quadratics is going to be the same. It's from negative infinity to positive infinity, or all real numbers. My range, okay? Well, I'm looking at my range. Since this is a maximum, I know that it's going to go from negative infinity and it's going to stop somewhere. And where do my y values stop? Well, my y values stop at 5. Actually, your vertex will tell you. So negative infinity to 5. And it stops at 5, and it includes 5. My increasing interval goes from here to here. So it stops at 0. So from negative infinity to 0. And then it starts again. It only has that other part is 0 to positive infinity. My real solutions, those are going to be my x-intercepts. And I'm just going to kind of approximate here. So it looks like it's about maybe approximately positive 1.5. And it looks like also negative 1.5. That's where it crosses, is here and here. Okay, the ones on the test you don't have to approximate. These ones you just kind of have to approximate. My y-intercept is where it crosses the y-axis, so it's going to be 5. End behavior. As x goes to positive, so on the right-hand side, and you're just going to do the same thing. It's going to say, let me just change this out of, and I apologize for the puppy going in the background. Negative infinity, so that's actually going to be on the left. Well, what's happening, my y? Well, for both of these, since it's concave down, okay, both of these are going to be negative infinity and negative infinity. My y values are going down. And then when I talk about my end behavior, well, this is going to be, negative infinity is going to be my left-hand side, and positive infinity is going to be my right-hand side. So we have just 2 more. I just want to try a couple more. So let's do this one right here. So for this, my a value is equal to 1, my b value is equal to -6, and my c value is equal to 11. First thing I do is I find my vertex. X is equal to -6 over 2 times 1, because it's negative b over 2a. So that's going to be 6 over 2, which is equal to 3. So that's the x value of my vertex. To find the y value of my vertex, I replace my x value with 3, so it's 3 squared, 6 times 3, plus 11. So that's going to be 9 minus 18 plus 11. So that's going to be -9 plus 11, which is 2. So I know the x value of my vertex is 3 and my y value is 2. So it's going to be 3, 2. Okay, so now I go 3, 2, 1. I pick 2 points to the right, so 3, 2, 1, and then 4 and 5 to the left, and I plug those in. So I plug it in, so 2 in to find my y value. So it's going to be y is equal to 2 squared minus 6 times 2 plus 11, which is going to be 4 minus 12, which is -8. -8 plus 11 is 3. plug 1 in, y is equal to 1 squared minus 6 times 1 plus 11, which is 1 minus 6, which is negative 5. Negative 5 plus 11 is 6. And plug it into the other side just to make sure. I'm going to just do this 4. So y is equal to 4 squared minus 6 times 4 plus 11. It's going to be 16 minus 24 is negative 8. Negative 8 plus 11 is 3 again. And then we have a 6 here. So I'm just going to graph those points. So it's going to be 2, 3, and then 1, 6, and then 4, 3, and then 5, 6. And there we go. That's my next one. Okay. So that's all you pretty much have to do with these. My vertex here is 3, 2. It is a minimum. My axis of symmetry is going to be x is equal to 3. My domain, all of your quadratics are going to be the same. It's going to be from negative infinity to positive infinity. Your range, okay, since it's a minimum, okay, your range is going to start at a point. Where do my y values start? Well, my y values start at 2, okay. They start at 2 and go to infinity. So if it's a minimum, it's the lowest point. So the lowest point would be, it's going to be some number to infinity. And if it's a maximum, it's going to be from negative infinity to some number. Okay. My increasing intervals, well, it's increasing from here to here. So, and where do my x values start? That's going to be from, it starts increasing from 3 and keeps going to infinity. Remember, you look at your x values. And in your decreasing intervals, well, it starts from the left-hand side, which is negative infinity, and stops at 3, or stops decreasing at 3. And then my real solutions, we're going to say none. Those are my x-intercepts. Again, same thing here. I just want to make sure I put that note. X-intercepts, your zeros, they're all the same thing. None, okay, because it doesn't cross. And then my y-intercept for this one, oh geez, sorry, you can't see it. My y-intercept is actually when x is equal to 0. And I should have rearranged this. So this is going to be 0 squared minus, so to find the y value, when x is equal to 0, so my y-intercept is where my x is equal to 0. 0 squared minus 6 times 0 plus 11. So my y-intercept is 11. I'll make sure it's the same thing. The ones on your test and on your practice, you actually can see the x and y intercepts. My end behavior for this is pretty easy. One's going to be negative infinity, one's going to be positive infinity. Since it's concave up like this, both of these are going to be positive infinity and positive infinity. So those are a little bit easier. I think we're good there. I think you only need to have the 2 examples. I'll make the 3rd example and just separate it if you do need a 3rd example of this, but it's